Okay, so let's take a look at another problem where they give us two pieces of information to start with, in particular a side and an angle, and we have to figure out everything that we don't know. So this is very similar to the last problem that we did in the notes. The next one we do is going to be different. Okay? I'm going to give you the case with two sides. Okay, but let's practice one more with side and an angle. Okay, so I'm going to put alpha over here, which means A has to go there. Once I've done that, everything else is automatic. What's the name of the bottom side? Not the position of it, the name of it. Yep, B. Yep. And what's the name of the angle at the top? Yep, beta. And the hypotenuse? Yep, C. Okay, so we've labeled everything. Everything that's a letter in that diagram, we need to figure it out. So we've got A, B, and C. A we know. B and C we don't. Alpha we know. And beta we don't. Okay, so you can find any of the three things that have boxes around them in any order that you want. Okay, which one, B, C, or beta, do we want to do first? Technically, any of them will work.
Beta.
Beta. Okay, beta would be the fastest one. What is beta going to be?
70.
Yep, and how come?
Because 20 minus 90, or no, 90 minus 20. 70.
Yep. So we got to make sure that alpha and beta add up to 90. So beta's done. All right, next we have to pick B or C. Okay, which one do we want to do next? Yeah.
I go with C.
We're going to do C. Okay. So what I do is I circle the one that I'm going to focus on, and I circle the two pieces of information that were given. All right. Those two pieces that I have circled for the sides, we got to know what their position is. What's the position of the side that's 12 units long? 12.3. Yep. Position, not name. Yeah. Yep. That is the opposite. And what's the position of side C? Yep.
Or no, that's hypotenuse.
That's
B is
hypotenuse. And B is adjacent. We don't need B yet, but we will. So it's a good idea to label it. All right. So now look at the three pieces of information. Opposite, hypotenuse. What trig function involves those two sides? Yeah, sine. So set up your equation. It's always trig function, leave room for the angle, and then your fraction. What is the angle that I'm going to be filling into the sine function? Yeah,
20 degrees.
20 degrees. And what's going to be the fraction on the other side? Yep, Lewis? 12.3 over C, opposite over hypotenuse. Now, this is one I just talked about in the homework. When you have the variable in the bottom, what did I say the shortcut is? If we don't remember it, we can go back through all the steps we did again, but it's easier if we can remember the shortcut. Yep.
Swap the function of the C.
Yeah, switch those two things. Okay. And the reason why I went through in the homework, you multiply both sides by C, and then divide by sine 20. But what ends up happening is the C and the sine switch places. So, all right. And that is the answer for C. So type it in, make sure you're in degrees, and round. Let's do 3 decimal places. When you type sine, it's going to open a parenthesis. Technically, you don't have to close it because there's nothing else you're going to continue typing. Right, so it's 35.963. Should I put a degree symbol on it?
No.
No, it's not an angle. That's a side. So don't put a degree symbol. Okay, so we've got A and we've got C. Should we use Pythagorean theorem to find B?
No,
No? Why?
because we figured out C wasn't a given.
Right. C wasn't a given, and if it's wrong and we use it, then we're going to mess up B. Even if it's right, it's rounded, so we're better off to not use it. All right, so let's finish this up by finding B. Okay, so look at what is circled in red. So here's B, the 20, and the 12.3. What trig function is going to help us solve for what is circled in red at the bottom? Yep, tangent, because it's opposite and adjacent. So tangent, angle, fraction. Okay. Angle this time is how much? 20. And the fraction on the other side. Yep.
12.3
B. Okay, this one is the same type as the last one. The variable ended up in the bottom, so we're just going to switch the B and the tangent 20. So B equals 12.3 divided by tangent 20. Since that's very similar to what I typed in last time, I can press second, enter if I want. It'll bring up the last thing I typed in and just change sign to tangent. Or just type the whole thing all over. It's not that much. Okay, so we get 33.794 if we round properly. 33.794. Okay, one thing you can check once you finish your table, make sure that the biggest angle in the problem goes with the biggest side. And the C is across from the 90. So yes, that is the biggest angle, and it is across from the biggest side. The smallest angle is with the smallest side, and the middle angle is with the middle side. Okay, so any questions on that type? All right, so we've done quite a few of the type where you get a side and an angle. Now we're going to look at the type where I give you two sides. This is different. It's not the same. Goal is the same. You still want to find all the sides and all the angles, but how we do that, you'll see there's something else, something that's going to come up. Okay, so in this one, they're telling you the hypotenuse and a leg. Measure 12.7 and 6.1. Which one of those numbers is the leg? I mean, they didn't write this in a super clear way, but it's clear enough you can tell. Yeah? Right. I mean, hypotenuse has to be the bigger number. So, and it says respectively, which means in the order they wrote the problem. So yes, the 12.7 is the hypotenuse, and the 6.1 is the leg. Do they tell us which leg? They did not. So in this problem, you could make the 6.1 either A or B. On the test, I will be more explicit, and I will say something like it is A, right? I'll tell you. Okay, so let's call the 6.1 A. So that means this is B, and the 12.7 is C. What would be the angle at the top? Just the name. Alpha. And the name of the one in the lower right? Beta. Perfect. Okay, before I go any further, can anybody just look at it and tell me what's different about this than the last two problems we did in the homework and the one I just did on the board? Yep. Okay, so I might have drawn my diagram different. As long as you keep A across from alpha and B across from beta, It's okay to do that. You can even draw your triangle, facing a different way. That doesn't really matter. Yep.
We don't know what alpha or beta are.
Right, we don't know either angle. Okay, so we're gonna have to. We can't subtract from 90 because we don't have one to subtract from 90. So let's make a table. And what did they tell us? A is 6.1.
You know that the other angle is 90 though, right?
Yes, we definitely know this is a 90. There's always a 90 in every problem. Alpha, we don't know. Beta, we don't know. B, we don't know. Okay. Let's start with B. Any suggestions on how we could find B? Yeah.
You could do a squared plus b squared equals c squared.
Okay, we could do the Pythagorean theorem. How come I think it's okay to do that this time, but I wasn't okay with doing it in every problem we've done so far? But this one I am. Yep.
Because on the other ones we had a degree to use, and this one we don't have a degree, so we can't really do that. Like we can't use sine or cosine to solve for anything because we don't have anything to.
Okay. Yeah.
We have two sides in this equation.
And why is that okay to use Pythagorean theorem then?
Because you wouldn't, if you didn't have two sides, you would have a variable equaling a variable.
Well, we reached a point in this last problem where I could have done Pythagorean theorem to find B. Because I got C first, I think. And I had A and I had C. And I could have used it. Yeah?
Because you always want to use the givens.
We always want to use the given. So the reason Pythagorean theorem is okay here is because you are not plugging in anything that you calculate. Right? You're only plugging in what was given. All right, so A squared plus B squared equals C squared. All right. So I'm not even going to do any of that out yet. How would I move the 6.1 squared over to the other side? Yep. Subtract it. I don't even care what it is right now. I'm not even going to figure that out. I'm just going to subtract the whole thing. So we move the 6.1 squared over to the right. And what's the last thing we'd have to do to get B and not B squared? Yep.
Square root. Well, you need square root of x.
So just say it one more time. Do what?
Square root it.
Take the square root on both sides. Yep. Just like that. And there's your answer for B. Okay, I didn't even need a calculator to do any of that out yet. I will now. But that's what I'm going to type in. And the reason I did that the way I did is because I didn't round anything off. This is exact right now. It's about to become a decimal. All right, so we've got the square root of 12.7 squared minus 6.1 squared. Okay, what you don't want to do is figure out what 12.7 is, round it. Then figure out what 6.1 is, round it. Then subtract the 2, round it again. And then take the square root of that and round it again. Now you've rounded 4 times. It's probably going to throw your answer off. Right now, I've rounded 0 times. Now I will round. Okay. 11.139. Okay. So that's how we find B. So when you have two sides that are given, Pythagorean theorem is okay to use. All right, next one. Alpha. Excuse me.
Bless you.
Thank you. Or beta. Doesn't matter which one. Which one do you want to do next? Yep.
Beta.
Beta. So I'm going to find beta. Because we are finding beta, we just made that our reference point. Everything now is from the perspective of beta. What position is side A? Yep. This is adjacent. What position is side C? Yep. Hypotenuse. We're never going to use B at all, so you don't even have to label it. I would never use B because B was not given. So don't even label it, and then you won't be tempted to use it. Okay. The two sides we have labeled are adjacent and hypotenuse. What trig function has adjacent and hypotenuse? Yep. Cosine. So far everything looks the same. Cosine. Leave room for your angle, and put your fraction. What are we going to fill in for the angle? Yep. Beta. And that's the difference. The variable this time is going to be the angle. It's not one of the sides. What's going to go in the fraction on the right side? Yep. What
Is it hypotenuse over adjacent?
For cosine, it's adjacent over hypotenuse.
Okay. So will that be 6.1 over 12.7?
Yep. Okay. Any questions up to that stuff? All right, so now what we have there is we have a variable that is an argument to a function. It's kind of like having something like this. That's a variable. Inside, it's the argument to the square root function. So adding, subtracting, multiplying, and dividing is not going to get rid of a function. The only way to get rid of a variable inside a function is another function. It's the inverse of the function, whatever would cancel out the one you don't want. So this is the square root function. What function cancels that out? Yep. The squaring function. So we square. We're not adding, we're not subtracting, we're not multiplying, we're not dividing. We're squaring both sides. Then the square and the square root function cancel out. You get x equals 25. Okay. Our problem is very similar. We have this letter inside the cosine function. We need to do something on both sides that is going to cancel out cosine. Does anybody know what function cancels cosine? It's not one we've talked about yet. Yeah? That would just make it the opposite. So that wouldn't cancel it out. Yeah? Is it what? Yeah, that's the symbol for it, a cosine with what looks like a -1 as an exponent. Does anybody know how to pronounce that? What it's called? So this is what we have right now. Do we have beta or alpha? Beta. So to cancel out a cosine function, you have to use inverse trig. So when you write a trig function with a -1, that -1 is pronounced inverse. So what you were saying was inverse cosine. There are two different ways that you can write the word or the name inverse cosine. The way you told me was the way on the left. The way on the right is another way you can write it. It's an older way to write it. It's arc cosine. But it means exactly the same thing. It's kind of like saying raised to the power of 2, or somebody else could say square. It means the same thing, just a different way to say it. So to cancel out a regular trig function, you have to use an inverse trig function. Every trig function has an inverse. We're only going to look at inverse sine, inverse cosine, and inverse tangent, because those are the only three that we need in this section. Is there an inverse secant, inverse cosecant, and inverse cotangent? Yep. We're just not, we're not using it. Okay. And when we are dealing with one of these functions, we want to be careful how we say to use it. Let's go back to this problem. If I was solving that, the words add, subtract, multiply, or divide would never come out of my mouth to solve that. What would is square both sides. That's how I would say to do it. Square both sides. Don't add 2 to both sides. Don't. It's not adding, it's squaring. Same thing if you had kind of the reverse of it. Now you're squaring. What function cancels out squaring? Yeah? Square rooting. So I'm not going to say add, subtract, multiply, or divide. What I'm going to say is take the square root of both sides. That's how you explain it. Take the square root of both sides. Right? And that's the word we're going to use a lot here. Take. Take the whatever of both sides. In this problem, we're trying to cancel out cosine. So what function will cancel out cosine? Yep.
Cosine -1 or cosine.
Okay, and how do we say it?
The inverse.
Inverse, yes. So inverse cosine. You can either say inverse cosine or you could say arc cosine. But don't say cosine -1. Just say one of those two, inverse or arc. So take the inverse cosine of everything that's on the left. And I don't have a lot of room, so I'm just going to try to put it in. Inverse cosine of everything that's on the right. When you take the inverse cosine of the cosine, it's like taking the square of the square root. They cancel out. So the only thing you have left now is beta. And then on the right, it's the inverse cosine of 6.1 over 12.7. I just use brackets because I had already used parentheses, and I don't like to use parentheses twice sometimes. That's why I used bracket. All right, that requires a button that I don't think I've shown you how to use. So to type in an inverse trig function, first thing you have to do is press second. Once you press second, then press either sine, cosine, or tangent. I want cosine. And that's it. That's how you type it in. Second, cosine. And then put in the numbers. 6.1 divided by 12.7. If you got 61.294, then you are doing it the right way. If you didn't, then you typed it in wrong, or something on your calculator is in the wrong mode.
Do you need a parenthesis on that?
I don't need one because I'm not typing anything else after it. If I put one, it doesn't change the answer. Where the end parenthesis becomes important is if you have more stuff to type in after it. Yeah. Okay, so 61.294. Okay, so there's beta. And let's see if we can figure out alpha the same way. Okay, if I only had about 5 seconds to finish and this was like a timed question and I just had to get it done, I would just subtract this from 90 and hope that I got beta right. But if beta's wrong and you subtract it from 90, guess now you just got alpha. So let's do alpha the same way we did beta. Alpha, C, and A. Now you're finding a different angle. Because you switched the angle you're trying to find, that name doesn't apply anymore. You switched your reference point. What is this side now? This side is now opposite. The hypotenuse is the same. Okay, that doesn't change. But what trig function has opposite and hypotenuse in it? Yep, sine. So that's how we're going to solve for the last angle. So, sine, leave room for your angle, put your fraction. Okay. The angle this time is alpha. And it's going to equal opposite over hypotenuse, 6.1 over 12.7. And if you're thinking that looks exactly the same as the fraction we did before, yeah, it is. 6.1 over 12.7. But it's sine, it's not cosine. So it's going to give us a different answer. Okay. So we've got a variable to a function, and we have to cancel out the sine function. What function cancels out sine? Yeah.
Inverse sine.
Inverse sine. And remember, don't ever say multiply, add, subtract, divide. The word you want to use is take the inverse sine of both sides. There is no multiplication in this entire problem. None. Okay. So take the inverse sine of everything on the left, everything on the right, and what happens on the left? Yeah.
The sine and the inverse cancel out.
Right, it's like square and square root. You just canceled it out. And now we type in inverse sine of 6.1 over 12.7. And that gives us 28.706. Okay, and if you check these two and add them up, they do add up to 90. If you don't trust me, double check it, but it adds up to 90. Okay, so that's the other type of triangle that you'll have to solve, where you have two sides. Any question on that type? So inverse trig is only needed when you have that type. If you're doing the top type, if you did the homework, you'll never need inverse trig. The only purpose that we're using inverse trig for is to calculate an angle. That's what inverse trig does. It calculates an angle that you don't know. That's just another one with two sides. Would I be using inverse? I'm not going to go through it. But would I use inverse trig or no? Wouldn't use it. Yeah. Right. Why would you need inverse trig here? Yeah.
Just two sides.
It's two sides. You don't know any angles, so you're going to have to use inverse trig. And Pythagorean theorem would be okay as well. But there'd be nothing different fundamentally about that problem and that problem. They both give you two sides. Right, so let's try this one. It says find the 6 trig values of an angle where 2, 3 is on the terminal side. Okay, let's draw that. Well, you don't have to use graph paper, but I think it might help you to visualize it. I think I can put it over there. Okay, so it says that the point 2, 3 is on the terminal side. All right.
What's terminal meaning of?
Well, that's my initial side. The initial side is where the angle starts. Terminal side is where the angle ends. So 2, 3 is on the terminal side. 2, 3. Just like that. So draw your terminal side through the point 2, 3. That's the picture of what they're talking about. Any question how I drew the terminal side? And the angle is right there. So we need to make a shape out of this to be able to do it. What shape do you think I'm going to make to be able to find all 6 of these trig functions? Yeah?
Oh, you're trying.
Yeah, I'm going to make a triangle out of it. And how do you think I'm going to make a triangle? Yep.
You just make a line, a vertical line going straight through, wherever that is, through.
Yeah, we're just going to draw a vertical line straight down right here. And there's your triangle. Now that we have a triangle, the rest of this problem you should be able to do. How long is the bottom side? 2. How tall is the triangle? 3. And the hypotenuse would be the square root of
Oh wait, no, I'm lying.
3 over 2.
no, so we just use a Pythagorean theorem to get the hypotenuse.
13.
Square root of what?
13.
13, yes. 4 plus 9. Pythagorean theorem. 4 plus 9. So the square root of 13. All right. Now just use that diagram to write everything down. That's it. Okay. What would be the sine of theta? Yeah.
Well, the beginning would be, it'd be 3 over the square root of 13.
Yeah.
But you need to simplify that.
Yeah.
So it'd be 3 the square root of 13 over 13.
Yeah. So there's the sine. What about the cosine? Yeah.
How do we decide where theta is?
Theta is always the angle between the x-axis and the hypotenuse.
Okay.
Always. It doesn't matter what quadrant the triangle ends up in. 1, 2, 3, or 4. Theta would always be in the spot that I'm putting it.
Okay.
Right there. X-axis and hypotenuse.
Bless you.
How about the cosine? What's that going to be? Caleb?
Is that
2 over,
2 over square root of 13.
and then when you fix it?
Hold up. Square root of 13 over 2. I got that far. I'm at square root of
Yep.
2 root 13 over 13.
2 root 13 over 13. Yep.
This root just
And what about your tangent? Yeah. Luke?
3 over 2.
Yes, 3 over 2. And now what do we do with all of the ones on the left to get the ones on the right? Flip them. Right? So this is going to be root 13 over 3. The next one is root 13 over 2. And the last one is 2/3. Okay. So what we just found is the 6 trig functions of theta. Did we actually find theta itself? No. Right? It's kind of the difference between, pretend like theta is like the name of someone. I don't have to know somebody's name to describe a bunch of things about them. Okay? All I'm doing here is I'm describing the sine of some angle, the cosine of some angle, the tangent of some angle. Maybe if I describe enough things about it, you would know what this angle is. Just like if I describe a person enough, you might be able to figure out their name based on how tall they are, hair color, eye color. I can describe all kinds of things, what they're wearing. But I didn't actually give you the name of the angle, like 37 degrees. We didn't do that. Okay? Well, let's figure the angle out. Any one of these pieces of information is enough to figure out the angle. Let's use this one. Sine of theta equals I'm just going to use 3 over root 13, just because it's shorter than the final answer there. So sine of theta equals 3 over root 13. How would I get theta by itself in that problem? And this, we just did this. Yep.
Inverse of sine on both sides.
Right, take the inverse of sine on both sides. Now you're figuring out what the angle actually is. What happens to the sine and the inverse sine?
Cancel.
They cancel. And we get theta equals, and again, I know I'm not using the proper format with the root in the bottom, but it doesn't matter because that's not a final answer. I'm just plugging it in to get a final answer. So inverse sine, 3 divided by square root of 13. Again, you don't have to close the parenthesis, but if you want to, you can. 56 point, it's going to round up, 56.31. Now let's go back at the picture and see if that makes sense. Does that angle look like it could be about 56 degrees? Yeah, it's more than 45. It's definitely more than half. But it's less than 90, so yeah, maybe it's 56. And that looks reasonable. Okay. Any question on that? Yeah.
When calculating for an angle, would you prefer rounding out to 3 decimal places?
Usually I use 3, but the problem with this one is it was 0.3099. So if I try to round to 3, well, it would be 0.300. So I just rounded to 2 in this case and called it 0.31. All right, now, if I gave you any point in this quadrant, I could give you a point here, or here, or here. Every point that I give you, you could make a triangle out of it somehow. And once you make that triangle, you're going to have a bottom side, and you're going to have a height, and you're going to have a hypotenuse. And you can always figure out what the angle is. You just have to know this coordinate. If I give you a coordinate anywhere in here, what's the angle going to be? Between. It's always going to be between, yeah?
0 and 90.
It's always going to be between 0 and 90 because that's in the first quadrant. Okay, so whenever we're in the first quadrant, super easy. We just have to do what I showed you. Inverse sine, and you get your answer. But what happens if the angle is in the second, third, or fourth quadrants? All right, so I made this kind of messy, so let me fix it back up. So we have 2, 3. And the angle is right there. Well, let's say you had negative 2, 3. What does that mean? Negative 2, 3. If you're trying to get to negative 2, 3, that's like going like this. Is that amount of travel that you have to do in purple going to be between 0 and 90? No, it's beyond 90. This is still your angle. This is called the reference angle. You still have to find this, but once you find it, it's not the final answer. What do you think you would do to figure out the size of that arc in purple if you knew this angle, which we do, it's 56.31? How would you use the 56 to get that whole section in purple? Yep.
Because we know like the rest of it that isn't the purple. We know everything except for the purple. So that's 180. Like the
Yeah,
reference
so it'd be
plus-
180 if you
yeah.
went all the way to here. Yep.
Yeah, and I mean, all that's left with the reference angle. Reference angle, purple, that's 180. You can subtract the reference angle
Yes.
by whatever the purple is.
So subtract that reference angle from 180. That's how you find an answer in the second quadrant. Okay, so the first step is to do inverse sine. That gives you the size of this angle that I just circled in blue. If you're in quadrant 1, you're done. That's your answer. If you're in quadrant 2, you have to take 180 and subtract the reference angle right there. And that'll give you the purple section. Okay. What about if we were in quadrant 3? -2, 3, down there. Step 1 would be find the reference angle, but then how would you find that green section? Rotating all the way to that point. Yep.
You subtract 270 minus the reference angle?
So to do 270 minus something, you'd have to know this piece
Oh.
outside there. Then you could say it's that much before 270, but we don't know this piece.
Okay.
Yeah?
Or could you add the reference angle to 180?
Yes, you can add the reference angle and 180. Yep, and that'll give you an answer in quadrant 3. And how do you know if you're in quadrant 3? Well, your x is negative and your y is negative. Both numbers are negative in the coordinate. Okay. And then quadrant 4. There's your reference angle. And if they want you to write an answer that's in the 4th quadrant, they're going to ask you for this. How would you find the amount of rotation in blue if you knew this reference angle?
Is it 360 minus?
Yes, it's 360 minus. Because you're basically, for the blue one, you're going all the way around, except you're not going around that much. So you take 360 and you minus the amount you didn't go. Yep. Now, if you were doing it in radians, what's 180 the same as in radians? Yep. 1 pi. So yeah, this could be a pi. This could be a pi. And what's 360 the same as? 2 pi. Yeah. So yeah, you can do it in radians as well if you want. So, kind of already did this. 2, -3. Well, that's the same point, right? I just made one of the values negative. So we already know the reference angle for this. How big was the angle when we did triangle with the 2 and a 3? Yep.
56.31.
Yes. So the reference angle is 56.31. Now, if 2, -3 is in the first quadrant, you're done. Is 2, -3 in the first quadrant?
No.
No. What quadrant is 2, -3 in? It's in quadrant 4. 2, -3. Here's your triangle. Here is your reference angle. Right here. This is 56.31. So how are you going to figure out how much that is? That's what they mean by find theta. Yep.
360 minus 56.31.
360 minus 56.31. So 360 minus 56.31. So that's 303.69. Okay, so what this is called is finding an angle that's basically in another quadrant. That's what you're doing. Finding an angle that's in another quadrant. And it seems like most people got that because everybody or the people I asked, they got all those formulas before I even showed them. If you just draw the diagram, it kind of makes sense. 180 minus, 180 plus, 360 minus. Those are the 3 formulas. Okay. Any question on that? So when we're working with the quadrantal angles, remember those coordinates are special. We talked about them on the unit circle. What was the coordinate for 0 degrees? Remember coordinate for 0 degrees on the unit circle? Nope, it doesn't have pi in it.
Oh, that's right. Oops.
Yeah,
1, 0.
it was 1, 0. And what was the coordinate for 90?
0, 1.
That was 0, 1. And 270?
Negative 1, 0.
Negative 1, 0. And, oh, that was, sorry, that's 180. And then 270.
Wait, 0 and negative 1.
0, negative 1. Because the coordinates for 0, 90, 180, and 270 are all 1s, 0s, and negative 1s, that's why these are the only possible answers you can ever get when you take the sine, the cosine, or the tangent of them. You don't get decimals, you don't get square roots. These are the only answers you ever get when you deal with the quadrantal angles. So that finishes up 6.5. Double check, make sure that's okay. So 25 to 32, those are all calculator questions. And then 40 to 42, those are solving. We already did 40 and 41 though. No, we did, I think we did 41 and 42 last night. So, let me fix that. So we did 41 and 42. So let's do 39 and 40.
I know, I saw that.
Is that final?
Maybe.
5 is good.
Buzzword. Choice? It's like low,
Yeah.
low candy.
That's the final one.
Do you know the looks max is here?
Yeah.
Sub 3, sub 5, sub 2 normie, mid 2 normie, high 2 normie.